Welcome to today's Explainer. We are diving straight into a fascinating new paper by Dan German called A Term-Rewriting Semantics for Pure Quantum States. Look, this research completely reimagines how we teach, learn, and really just approach the math behind quantum computing. So, if you've ever felt intimidated by quantum mechanics, well, you're absolutely going to love this.
I want to start by challenging a massive assumption, one that's dominated the field for decades, honestly. It's this idea that you need a PhD in advanced calculus and linear algebra just to grasp the absolute basics of quantum mechanics. Which, begs the question, can middle schoolers actually do quantum physics? Thanks to the research we're unpacking today, the answer is leaning toward a resounding yes.
To understand why, think of traditional quantum math as this incredibly heavy, honestly kind of irrelevant backpack that you're forced to carry up a mountain. The author points out that learners are weighed down by what initially seems like totally irrelevant math, but this new approach, it uses simple arithmetic. It literally allows you to drop that heavy backpack and still climb the exact same mountain, reaching the heart of non-trivial quantum theory without all that exhaustion.
Section 1. The Quantum Math Barrier. Let's look at that intimidating math keeping so many brilliant minds out of the quantum realm.
Before getting to the actual physics, first-time learners usually hit a massive wall of dense, super intimidating mathematical apparatuses. The paper explicitly argues that beginners have to absorb a huge amount of complex math before they can even touch the real quantum concepts. It's an overwhelming barrier, right? And it's keeping people out of a field that desperately needs fresh, innovative thinkers.
Section 2. Enter the misty states. This is our transition vehicle to bypass that barrier.
So back in 2017, Terry Rudolph introduced a truly revolutionary concept. He created an elementary rewriting system designed to accurately describe the basics of quantum circuits to high school and middle school students. Fast forward to this July 2026 paper, and Dan German has just brilliantly expanded upon that foundation, testing its limits and pushing it into some incredibly advanced new territory.
The absolute crucial concept here is what we call misty states. Basically, think of it as a term rewriting system for pure quantum states. Instead of relying on vast matrices and complex numbers, it relies on simple arithmetic to describe quantum circuits and computation. It takes the abstract and makes it totally tangible, readable, and highly accessible for a first-time learner.
Section 3. Universal Power, Simple Math.
Now, you might be thinking this is just some dumbed-down toy model, but it's universally applicable. It achieves good enough accuracy with really minimal overhead by using a tiny universal set of gates. Plus, it leverages foundational mathematical proofs by Yaoyun Shi and A.Y. Kataev, which means the simple arithmetic is built on incredibly robust, mathematically sound architecture. It's practically a cheat code for quantum computing.
Take this direct quote right out of the abstract. Every calculation can be done to good enough accuracy and perhaps with a small overhead using just a tiny universal set of gates. The author is making it crystal clear here. You are not sacrificing the integrity of the computation when you use this simple arithmetic approach. You can literally do any quantum computation with this universal system. Section 4. A bridge to real physics. And remember, this is not a total replacement.
German specifically notes in the paper that we shouldn't try to recast all of quantum theory into this formalism. The conventional quantum mathematical apparatus still has its vital place, sure. Instead, the misty state picture acts as a transition vehicle. It's just a highly effective way of getting people to the core of non-trivial quantum theory first, before they have to tackle all that heavy math. Think about how perfectly this maps a new learner's journey. You start at step 1 with the misty formalism, using just simple arithmetic. This allows you to smoothly glide right into step 2, where you actually grasp the core quantum theory without that crushing math burden. And once those concepts are fully locked in, step 3 becomes so much easier. It's a natural transition to the full conventional quantum mathematical apparatus. It basically flips the entire traditional learning model completely on its head.
Section 5. Extending the misty formalism into entirely new frontiers.
In the paper, German starts by meticulously reviewing Terry Rudolph's original 2017 proposal. He considers its incredible strengths, but also, its limitations. To prove its viability, he actually shows the original formalism in action through a complex process known as entanglement swapping, which is essentially teleporting quantum states between particles. But he doesn't just stop there. He really pushes the boundary.
Building on that demonstration of entanglement swapping, German extends this foundation into some entirely new advanced territory. He evolves the whole system to handle concepts that would usually require a massive blackboard full of dense equations. He does this by introducing a brand new category of what he calls irreducible MISTY states, and these act as fixed mathematical points. With this framework in place, he successfully models the GHZ game, a pretty famous quantum thought experiment involving multiple entangled particles. And he proves that even these highly complex quantum states in games can be completely expressed through this accessible term-rewriting semantics.
Which brings us to a really profound realization. As we wrap up this explainer, I want to leave you with this final thought. If we can use simple arithmetic and a term-rewriting system to make the deep complexities of quantum computation accessible to middle schoolers, what other quote-unquote impossible scientific barriers are just waiting to be rewritten next?